It is 6:47 in the morning. You check your AI provider dashboard. You see 437 API calls last night. You did not make 437 API calls last night. You owned the key. You did not own the bridge. In the earlier API key video, we used the simplest version of the explanation. An API key is a controlled permission slip. That is still true. But once you start building real workflows, AI tools, creator tools, voice tools, research tools, automation systems, the API key stops being a technical detail. It becomes the anatomy of the bridge. This video is part 2. We open the bridge and look inside. This channel has a doctrine for technical depth. We call it tech detail level. Inspired by DefCon levels, except instead of military readiness, it signals how far down the rabbit hole the video goes. Level 1, practical anatomy. What the key looks like, what it carries, where the system stores it. The level a serious creator needs to make ownership decisions. Level 2, provider-side internals, signing algorithms, token lifetime, scope claims, rotation windows. Level 3, full cryptographic mechanics. HMAC construction, JWT signature verification, replay defense math. Today is level 1. If you want level 2 or level 3, drop a comment with L2 or L3. The comments decide. Most creators meet 5 key families in practice or, as of May 2026, OpenAI issues project scoped keys with the prefix sk-proj. Older sk-keys are phasing out. Anthropic issues sk-ant-API 03 for full keys and sk-ant-OAuth 01 for workspace scope tokens. AWS issues access keys starting with AKIA. Those are HMAC signed credentials. The request itself carries a signature, not just the key. Google issues either AIza API keys or service account JSON files containing private keys that sign JWTs. Stripe issues sk_live and sk_test keys, plus restricted keys rk_live that scope what the key can do. Most people treat all 5 families the same way, like a kitchen appliance manual. Page 1 says, "Congratulations on your purchase." Page 2 says, "Warning, do not disassemble," and most users stop reading there. The API key prefix is page 1. The signing model is page 2. We are reading page 2 today. There are 3 anatomical models, 3 different things hidden under the phrase API key. Model A, opaque string. The key is just a long random identifier. The server looks it up in a database, checks scope and rate limit, lets the call through. Most OpenAI, Anthropic, and Stripe keys work this way. Model B, JWT. Header.payload.signature. The key carries information inside itself, who issued it, when it expires, what it can do. The server verifies the signature without a database lookup. Google service accounts use this model. Model C, HMAC signed request. The key never travels on the wire. The client uses the key to sign the request, and the signature travels. AWS works this way. 3 models, 3 blast radii, 3 rotation stories. This is the part most creators never check. Where does the key live? The moment after you paste it into a tool. On Windows, well-behaved tools use DPAPI, the Data Protection API. Keys are encrypted with your Windows login. No prompt, silent. On Mac OS, well-behaved tools use Keychain. Each item carries an access control list. Touch ID can be required before release. On Linux, the convention is libsecret, talking to the secret service. The architectural footnote: any application running as your user can read any other application's secrets. There is no inter-app protection on Linux. It is a known design boundary. As of May 2026, if a tool stores the key as plain text, in a config file, in local storage, in a JSON next to the executable, that is a 4th answer, usually the wrong one. The most common API key leak is not a sophisticated breach. It is one developer pasting a key into a Slack thread to debug something 3 years ago, and Slack Search still finds it on demand. The key is still active. The developer who pasted it left the company in 2024. The thread participants forgot the conversation existed. The key did not. Git Guardian's State of Secrets Sprawl report, published in 2026 with data as of May 2026, counted 29 million leaked secrets in 2025 alone. A 34% year-over-year increase, the largest single-year jump ever recorded. 81% of the surge came from AI service keys. 70% of secrets exposed in 2022 are still active today. 70%. The key you forgot about is probably still working. Every key carries a scope, what it is allowed to do. Most creators never check it. An OpenAI project key scoped to a single project cannot drain a sibling project's budget. An Anthropic workspace scope token can be read only or read write. A Stripe restricted key can be read only for charges, write only for refunds, or any specific combination. An AWS access key inherits IAM policies, and an IAM policy can be 12 lines or 1200. Scope is the half of the key that decides the blast radius when it leaks. The prefix tells you the family. The scope tells you the cost of failure. Rotating a key, replacing the old key with a new one, sounds like cleaning a coffee filter. Routine maintenance. In practice, in a production workflow, it is more like open heart surgery on a patient who is still running a marathon. You issue the new key. You deploy the new key. You watch the old key for drainage. You retire the old key only when no traffic has touched it for some quiet period. And if you forget any of those steps, something stops working in production at 3 a.m. That is why most creators never rotate. And that is why the leaked 2022 keys are still working in 2026. We just talked about 5 key families, 3 signing models, 4 storage locations, 2 halves of every key. That sounds like a lot. There is a 1-page card that holds all of it. 7 anatomy checks you can run against any tool you use. We will get there. First, 3 more things. Some tools, increasingly the better ones, do not give you a long-lived API key at all. They give you an OAuth client. You log in once. The tool receives a short-lived access token and a longer-lived refresh token. The access token expires every hour. The refresh token swaps it for a new one. The refresh token itself rotates. Each use issues a new refresh token and invalidates the old one. This is called rotating refresh tokens. It is a replay defense pattern. If a stolen refresh token is used, the legitimate client's next refresh fails and the breach is visible. OAuth is the model where the breach has a clock built into it. A leaked token has a half-life measured in hours, not years. The opposite pattern is what most low-budget tools still do. You paste a long-lived key into a settings page. The tool stores it. The tool uses it forever. There's no expiry. There's no rotation. There's no audit trail you can read. This is the throw the key into the tool and wish it luck pattern. It works fine until the day it does not. And the day it does not is rarely a calendar day you control. Here is the part developers do not like hearing. The most common place an API key is found in a leaked GitHub repository is not in the credentials folder. It is in a comment. A developer hard-coded the key while testing, said, "I will remove this before commit," and then did not. The repository indexes the comment. Search engines index the repository. The key sits there like a recipe written on a fridge magnet, except the kitchen is the public internet. 32.2% of internal company repositories, that is the Git Guardian number, as of May 2026, contain at least one active secret. Internal does not mean private. It means we trust the people who can see it. That is a different sentence. Every provider gives you a usage dashboard The dashboard shows token count, request count, billing total. The dashboard is not yours. You rent it from the provider. The provider decides what columns exist, how long data is retained, what gets exported. The dashboard is helpful. Until the day you need a piece of information the dashboard does not show, and there is no escalation path, because you are a self-serve customer. The dashboard is not the bridge. The dashboard is a window into the bridge that the provider rents to you. That is fine, as long as you know it. The card on the resources page works in 2 passes. Pass 1, Section A, 5 fillable lines. You write down the tool you use, the key family it asks for, the scope, the storage location, and the rotation cadence. 5 lines, 1 tool at a time. Pass 2, Section B, 7 anatomy checks, prefix matches, unknown family. Scope is the smallest that works. Storage uses OS level credential protection. Rotation has been tested at least once. Revocation path is known. Usage dashboard has been opened in the last 30 days. Refresh token pattern is preferred where available. Then Section C, the threshold. 6 or 7 yes checks. You own the bridge. 3 to 5. Patch first. Less than 3. You do not own the bridge. You rent the illusion of one. That was level 1. The anatomy a serious creator needs. If you want level 2, the provider side internals, signing algorithms, token lifetime math, scope claim parsing, rotation window economics. If you want level 3, full cryptographic mechanics, HMAC construction, JWT signature verification step by step, replay defense math, drop a comment with L2 or L3. The comments decide which one we make, or both. The card is on the resources page, Faceless, YouTube, Automation, HQ.com/resources. The page hosts 7 cards. This one is Video 9, API Key Anatomy. Section A is 5 fillable lines. Section B is 7 yes or no anatomy checks. Section C is the threshold, email gate, confirm link, PDF lands in your inbox. Same Cloudflare turnstile and double opt-in flow we use for every card on the door. And if you have confirmed before for any other card, the page recognizes that via a privacy-friendly cookie and skips you straight to the download. No second confirmation email, 5 keys identified, 7 anatomy checks, 1 threshold. Own the bridge, not just its label. Next. The moment the bridge is yours, a different question shows up. What is the cost of staying faceless versus going on camera when you already own every other piece of the workflow? Spoiler, it is not the answer most creator coaching content tells you. See you on the next one.